Hi. So far, we learned how to write sets and how to denote them, and what are the elements in a set, and what are the different types of sets that we usually observe, like empty set, subset, universal set, and what is the meaning of them. And we learned most of them. Now, we are going to learn about Venn diagrams. So, what diagram? You know what is a diagram is? Like a pictorial form of showing something, right? A picture kind of a thing, diagram. So why we in math, physics, chemistry, in all these forms, why we go with diagrams? Because in English there is a saying, right? So a picture is worth of thousand words, right? So by looking at the picture itself, you can understand what kind of a picture it is. So why it is like that? So because our brain has a power to understand pictures very easily, rather reading the paragraph of words. So that's the reason it's always like movie is more interested than a novel. So but novel is some people like novels too, books also. But why pictures? Because many people like pictures, movies. Why? Because it is our brain is more uh, easy to understand those things. That's the reason, okay, movies are more popular than books, because that is that is using pictures to explain something. Okay, we learn about Venn diagrams. So Venn is a mathematician who started these diagrams first. So that's the reason all these diagrams are called Venn diagrams. So the spelling is VENN, Venn diagrams. Okay, so in this diagram, so we mostly see a big box and some circles in it. Okay, there will be any circles. So this Venn, okay, he prepared a box, a big box. So he assumed this box, okay, we will see the elements and this one. Okay, and these circles, so generally in your 10th class, so you deal with two circles only, not many, only two circles. So what is this rectangular box and what are these circles exactly? We will learn more about it. Okay. So what this Venn diagrams? So if you look at these Venn diagrams, the big box. So when thought like this big box, he thought like this is a universal set. So you know how we denote the universal set? Mu. We write it at the corner. Okay, mu. So what he assumed, every element. So look at the language, what I'm using, elements, sets. So I'm using the what is the vocabulary of the sets. So the this mu is a universal set and every element present in this box. So he assumed that, okay, this is my mu. That means mu is what? Universal set. It should have everything in it. So this is my mu. And he assumed that, okay, every set represents a circle here. This is my set. Yes. This is another set. Or all these sets represents, all the circles represents different sets. So for example, mu, let's go with our regular example, like what is mu? All stamps, our stamps example, released by Indian Postal Department. Postal Department. So if you take this as mu, so this represents all the stamps, like 1, 2, 3, 10, 11, every stamp. Okay, these stamps are everywhere. So And we have a set, right? This is my collection. What is my collection? My collection has 1, 2, 3, 4, 5, 6. And some Ranga's collection is 7 or 8 stamps. So I collected stamp 1, stamp 2, stamp 3, stamp 4, stamp 5, stamp 6. And Ranga's collected stamp 7 and stamp 8. Think like that, okay, these two. This Mu is the Indian Postal Department, so they have everything. And each circle represents a set. So this, I want to represent yes. So I have to draw a circle. When I draw a circle, then what are the elements in this one? I have 6 elements. 1, 2, 3, 4, 5, 6, right? And Ranga has 7 and 8. 7 and 8. This is how we represent Venn diagrams. But you know the circle, or to say this mu is a universal set. It won't have duplicates, right? So 1, 2, 3 we erase from here. Anyways, if it is inside the circle means stamp 1 is inside the circle. That means it is inside the big box also, isn't it? 1 is inside the circle means entire circle is present in this big box. That means if I say 1 is inside the yes means I can also say 1 is inside the big box also, isn't it? So if somebody says like, okay, I have a pen in my front pocket of my shirt means it is also in my shirt too, right? So I have $100 in my bank account means I have $100. So likewise, so if a number is inside the circle means inside the big box also, right? So it's the same thing. Like, okay, I have chicken in my kitchen. That means I have chicken in my home too. So home is bigger than the kitchen. So I can say I have chicken in my home also. Likewise, if 1 is inside a circle, this particular set means it is also present in this big box. This big box is universal set. So this is all about the Venn diagram. So you will be having a big box that represents all the elements, that holds all the elements, like our Indian Postal Department who is holding all the things. So whereas S and R are small sets. We can have another one also. Some who is that? Ashwini. Ashwini has number 10, number 11 stamp. So this is Ashwini's circle. She has only 10 and 11. So no need to represent duplicates. So all we do is remove the duplicates from here. As long as it is inside this circle means it is also present in mu. So there are stamp 13 and stamp 14. Nobody holds it. Only Indian Postal Department has it. So that means 13 and 14 will be inside this box. It doesn't belong to any circle, but it will be outside of all the circles. So but inside the big box. This is how we represent the Venn diagrams. So let's revise ourselves. So there will be a big box that represents a universal set mu and it holds everything. And individual sets we represent with circles and we denote a letter next to that circle, and each circle represents a set and we write all the elements of that set inside that circle, because 1, 2, 3, 4, 5, 6 belong to mine. So I'll write it. These are Rangas 7 and 8. We write it like this. And this is Ashwani. So 10 and 11. This doesn't belong to anyone, but it is in the universal set. So it will be here. So now you know all the parts of the Venn diagram. So why we use means, so look at this one. Mu, S, R, A. So each has, okay, this is having set builder form, this is roster forms. So 1 2 3 4 5 6, when your eye sees this big a listed form, it is very difficult to, your brain will take some time to process it, what kind of a stamps that S is holding, so what kind of stamps that Ranga is holding. So it will process, but it will take some time. But look at this diagram. By looking at this diagram itself, you get a picture that, oh, Ranga is holding 7 8 and Yes is holding 1 2 3 4 5 6. Okay, Ashwani 10 11. Okay, 13 14 are, okay, nobody holds it. Okay, good, I get it. So that's the reason we go with diagrams. So pictorial form is easy to, our brain will easily process within less time. That's the reason we go with the Venn diagrams. So since Venn started it, we call it as a Venn diagram. Thank you. Now think about a situation. Okay, so here I'm holding, I got collected stamps 1 2 3 4 5 6, and Ranga collected stamps 7 and 8. One day I went to the post office and I also purchased stamp 7. Then I have to, in my roster form, how I will represent if I buy a new stamp. So my collection is, now I added 7 also to my list. So now I am holding 1 2 3 4 5 6 7. So I have different 7 different stamps. 7 is common in both mine and Ranga's. So how I will do it in pictorial form? So if I want to put it in here, I have to draw 7. There is a 7 here, there is a 7 here. So if you represent individual sets, okay, all unique elements, good. Ranga also unique elements, good. But when you consider mu, this is also another set, Indian Postal Department Service. There is 7, 7, duplicates are there. We can avoid the duplicates. How we can avoid the duplicates? So Venn created a way to represent that one. So when the common elements are there with two sets like mine and Ranga's, so he said that, okay, we can represent in a different way. We can get these circles close to each other. And we will write a common element here, 7. So let's write 1, 2, 3, 4, 5 and a 6. Here we will be having only 8. And 13, 14, nobody holds it. So we write outside freely. If you look at this one, this 7, this is my yes, this is Ranga's. If you look at Ranga's circle, that is this one. If you take Ranga's circle, so let me put some lines. Okay, if you take Ranga's circle, so Ranga's circle is this much. So he is holding 7 and 8. So that's what it is. Ranga is holding 7 and 8. Good job. And what is my collection of stamps? 1, 2, 3, 4, 5, 6, 7. So what is my circle? My circle is here. Okay. In my brown circle, how many are there? 1, 2, 3, 4, 5, 6 and a 7. Even it is satisfying mine and Ranga's. So when there are any common stamps between two sets, we try to represent in the common area. This is our common area. This part will be both in S and R. So this is how we represent. So when we want to represent two sets which have common elements, we will write like this. Okay. So if no elements earlier, okay, when yes didn't buy the stamp 7, these two are individual, like, okay, there is no intersection point because they don't share any common things. We can write like this. So they are separated. This is yours, this is mine. Okay, we don't have any common things. So here common things. So this is how we represent when there are any common elements. So yeah, that's about when how to represent when there are common elements. Okay, let's take one other example. I went to the shop, postal office, and I got the stamp 8 also. I got the stamp 8 too. Okay, now how I have to represent? So as usual, we discussed there will be a big box that will be representing all the stamps mu, and we represent each set as this is S set, and for R we have to write another circle, and since these two are having common elements, we will be having like this, isn't it? So when we do like this, what will happen? So here I will write my own elements 1 2 3 4 5 and 6. 7 8 are common elements. I'll write 7 and 8. But what about Rangas? So Rangas 7 8 8 went into this common area, so this is totally empty. So what Venn said is, okay, when we do such a thing, so we can write R subset of S, isn't it? Every element in R present in S. 7 is every element. Let's take the first element 7. It is there. 8. It is there. Good. When both the elements are there, R subset of S. Good job. But in this case, he said we have a nice way to represent them. Rather this one and keeping this all this as an empty space, he said, okay, let's form a different way. So in this one, so we will take the small elements is a small circle, that is R, and we will put 7 and 8, and yes, we will make a bigger circle. Yes, since every element of R is present in S, so we can take entire circle into S, and S has extra elements. What are they? 1 2 3 4 5 and 6. So my R has 2 elements, 7 and 8. My S has extra elements which are outside of this circle, inside of S. So that's how we represent. So by if somebody looks at this one, we can easily say, oh, okay, R holds 7 and 8 stamps. Oh, S is holding a few extra stamps. That's how we get, our brain gets the picture of it. So this is how we represent when all the elements of one set is present in the other set. So circle inside a circle. Thank you. Okay, let's do the simple recap. So what is a Venn diagram? Venn diagram has a big box which is having a mu universal set, and so let's take two circles. Since what to say, your 10th class board has only two circle things, so two sets, you deal with only two sets. So when you have two sets, what are the types? Two circles not touching each other, or you will be having another type. Two circles are little bit inside, having common space, or there is a third type where one circle is totally inside of other circle. So let's take if it is A and this is B. So this is A, this is B, two different sets, and they are not having any common elements. So when they don't have any common elements, we separate them. They are not having any common stamps. So A is a person having a set of stamps, and B is having a set of stamps, they don't have any common stamps. So we don't touch them. So here, if they have common stamps, so we need to have some common area. So to represent the common area, we have to draw two circles touching each other with a common space like this. When two circles, okay, one is totally inside the other, like, okay, so whatever B has, so A is also having all those things. Then we push B into the circle A. So two circles not touching when they don't have any common things. If they have any common things, we have to draw in such a way that they intersect. So in other way, if all the elements of B inside A, we have to draw a circle inside a circle. So only three types: type 1, type 2, type 3. So whenever you read a question, it will fall in this category or this category or this category. So let's discuss. When you read the problems, you will understand. Thank you.